Welcome to The Gig. I'm Johnny O, your host, and we talk about all things tech. Today, I want to talk about networking and not home networking. I want to talk about enterprise networking or industrial networking. And we're going to do this in 3 segments, Layer 1, 2, and 3. And I'm going to start with Layer 1. Layer 1 is called the physical layer. This is where your access points, your Wi-Fi access points, your firewalls, this is where they exist. It's called Layer 1 physical layer. It's also where your network card would be a Layer 1, your MAC address would be a Layer 2. I'll describe and discuss all this as if you're not engineers. So I'll try and take the engineering out of it so everyday people can understand enterprise networking and how it works. Enterprise networking is divided into 3 network layers, and they call them network layers. Because in the OSI model, there's actually 7 layers. The first 3, Layer 1, 2, and 3, are all networking. The other 4 are what we call software layers, or they exist on a server or within an operating system of a computer or server. So those are the software layers. And these 3 layers are not written in stone. I'm going to start with Layer 1, physical layer. This is where you find firewalls. On enterprise, we call firewalls NATs, Network Address Translator. Any device you come across, whether it's a switch or a router or a Layer 1 device, and there's a service on it called a NAT service, that's a firewall. Whenever you see NAT, that's firewall. Network Address Translator. Routers have them, switches have them, obviously firewalls. The difference between a NAT service on a router and a NAT service on an actual NAT or firewall is the firewall will do a lot more deep packet inspection. I'm talking about real firewalls. Cisco ASA series, Juniper firewalls, these are very good, high quality industrial firewalls. Oh, by the way, I should mention, if you're a Mac user, don't worry about listening to this. You don't care about any of this. None of you work in enterprise. The only Mac users I saw that worked in enterprise networking used Linux on Layer 1, 2, and 3. And the systems they built completely sucked. And he's logging in with his Mac, and he's got his Linux server, and it was shit. I swear. Oh. Okay, I'll go into more detail about that and how shitty it was later. Now, Layer 1, Layer 2, and Layer 3, the networking layers, are where Cisco makes all their money. Cisco, the entire corporation, is based on these 3 layers. They're called the network layers. Juniper, that's another company that makes all its money on these 3 layers. Some companies just make Layer 1 equipment and some Layer 2 equipment, like Linksys and D-Link. They're just on Layer 1 and 2. That's it. Okay, mainly Layer 1 access points. Cisco, Layer 1, 2, and 3, and their products are divided that way too. So if you look at ASA series, they call the scripting language ASA now, but it comes from a scripting language called PIX. And all Cisco Layer 1 devices use the command language or a scripting language called PIX. They call it ASA now because they've put them all together. Whether you're running a 5 series, 6 series, or 5500 series, you can use the same script. Now, the other 2 layers, Layer 2 and 3, use an operating system called iOS, or Inter-Networking Operating System. That's right. iOS is a Cisco operating system, not a Mac phone operating system. It's called Inter-Networking Operating System. That's what Cisco Layer 2 and Layer 3 devices use. But we're talking about Layer 1, so we're talking about ASA or PIX. It comes from PIX. They call it ASA now. With that, you also have Juniper devices. I'll explain the difference between Cisco and Juniper in a minute. Cisco are obviously number 1. On Layer 1, 2, or 3. Cisco's it. The reason is they do the research and development. For the new speeds, the new networking speeds, and new networking cards, there's 10 gigabits and 40 gigabits. 3 years ago, starting 5 years ago, Cisco did all the R&D. What that means is they didn't just come up with the idea. When they're a big enough corporation, when they come up with an idea like that, then they determine what the best design is for the network CPUs in the equipment and to process those packets and the best design. And they patent all the hardware. And they patent the software too. So, for example, there's a Layer 1 protocol. And it's for terminating VPNs, virtual private networks. Now, if you're talking about an enterprise VPN, you're talking about a real VPN. I'm not talking about a home network VPN where you log into a gateway for a service so you can have some privacy and whatever. No. Real VPNs are encrypted tunnels that say bank. If you're going from one bank to another bank, they'll use a VPN, an encrypted tunnel. The encryption's a lot more sophisticated than the home VPNs that you use as a service. Now, when I'm talking about VPNs, I'm talking about enterprise VPNs, device to device. You must have a Cisco device on one side and a Cisco device on another side. And they're not cheap. So these are enterprise or what I call industrial VPNs. Now, there's a protocol where I was working on a network. And from this network, I wanted to come in from a server. I terminated to my Cisco device, and then I wanted to go out to another network, another server, over another VPN. And to do that, it's called hairpinning. And only Cisco devices are capable of this, coming in on one VPN and then going out on to another network from that device on another VPN. So you have encryption in, process, encryption out. Only Cisco devices can do this. And it was for remote management on an industrial system or enterprise system that we needed to do this. A Juniper device could not do this. In fact, I was trying to terminate just the first phase of a VPN on a Juniper device. The Juniper engineer did not help me at all. I actually had to go and figure it all out on my own, call the engineer back, and tell them what they had to do to terminate to this Cisco device from their Juniper. It was a total pain in the butt. I was not impressed at all. And that's when I started taking a closer look at their gear. And I realized, well, if they're using software and techniques within their software that Cisco has patented, they have to pay royalties to Cisco. And in fact, they do. Now, I'm not saying for sure, and I'm not going to give specifics, but Cisco is the one that does all the networking research. And they're the first ones to the table with the patents. And if they're the first ones to the table with the patents, they're the first ones to the table with the hardware patents as well. And on Layer 1, Cisco makes a lot of money on Layer 1. Their firewalls are amazing. In fact, they have logging and things you can do just on the Cisco network. Like Cisco will be monitoring your network as a service type of thing on your Layer 1 device. It's some sort of service you can pay for from Cisco. I don't really like that idea, but I would rather have the machine do that and then record the log somewhere else. Another thing that we do on Layer 1 is a lot of the logging. That's where the logging is for who's coming in, who's going out. And those logs are sent out once every 5 minutes or 10 minutes to a separate email account. So hypothetically, if you were to breach that network in some illegal way or something like this, and you take over the whole network, you still will get caught. They have your footprint all over the place. They'll know when and where you're connected from. So these devices are quite sophisticated. Therefore, it makes sense when security consultants, what they say is, most network hacks come from the inside. 90% come from inside the company. That's right. Because the firewalls are so good these days that you must find an alternate way through. You're not going to come through the firewall. Unless you hack someone's account or something like this, you get a crypto key from somewhere, it's not going to come through the firewall. The breach won't really come through the firewall. They are that good. Another thing your firewall does, your firewall gives you VPN access. So if you work at a corporation and They want you to work from home for the weekend. They'll give you VPN access. That VPN access will terminate to their Layer 1 device, generally speaking. But there are software VPNs. There's like some Linux garbage that they use, OpenVPN they call it. Total junk. I mean, there's some companies that can use it effectively, but because it's open source, they seriously modify the code to be able to use that. It's just junk. One of the worst examples of networking was a Linux firewall that some Mac noob set up. He wasn't a noob. He was actually a pretty smart guy. He just had the wrong idea. I mean, this guy would be a superstar if he learned Cisco networking, like all the networking stuff that he knows, instead of using it in Linux and this sort of thing and applying it to Cisco equipment. He would be a superstar. But he's so ideological about Macs and about Linux, it really, I think, will hurt his career until he gets on Cisco, gets on some real gear. So the thing about Linux is it comes from networking. All the original networking was done from Linux systems. And you'll notice that your home networking devices, your Linksys, your D-Link, TP-Link, your Netgear, Wi-Fi devices, what they run on an embedded version of Linux. They embedded, that means they've programmed that and written the chips on the boards in the devices in Linux. So everything you see, you're doing in Linux. It's a click. The interface is obviously, they have a nice interface with the web page, a local web page, and you're changing the settings by basically clicking on a web page. Okay, so it's in hypertext, nice web page, but it's actually Linux. The whole thing's running on Linux. All networking ran on Linux at one point. At one point, they only had servers. They didn't have routers. They've always had switches, but they didn't really have firewalls either. In the early 90s, you heard of firewalls, and even in the 80s, we heard about the firewalls. They were very rare. The closest thing we had in Windows in the Windows 95 days was something we called port blockers. We'd block port. We'd have a software tool to block our ports. They weren't even firewalls. But that port blocker would be a Layer 1 software tool. What Linux does is they take Layer 1, 2, and 3, and they deploy them as APIs, application layers. Now, in theory, in a Linux server, you can deploy code, blocks of code that integrate with your kernel, that make that server into a router, or they make that server into a firewall, or they make that server into a VPN concentrator, or they make that server, well, you can't really make the server into a switch, but you can do switching with it. And it's all deployed in Linux, and it's a horrible way of doing it. Because if there's a power failure, and that's how you've set up your server and your whole network, all layers 1, 2, and 3 are on the same server, guess what? Layer 1, 2, and 3 just went down. You didn't have a firewall go down or a switch go down. The whole thing, the whole network is gone. And in fact, the example that I gave you of this really smart guy, I thought he was a smart guy, but he would only use Linux for networking. He was ideological about it or something. He had something against Cisco. I don't know what, but he was a complete freak, total nerd. But anyways, he refused to use Cisco gear, knowing that it was technically superior to what he was doing. So he had an enterprise deployment, and he made 2 servers. On each server, he had a redundant system. So the firewall configured on the main server was also configured on the backup server. And the switching, there wasn't any switching on the servers, but the routers, the same thing. And the VPN concentrator, because there was a lot of VPNs coming into this system, they were replicated. So it was in redundancy. Then he took another Linux server, 2 of them actually, and turned them into, with his configuration skills, he turned them into load balancers that he made himself at home in Linux. He wasn't a programmer. And so what happened is I got a frantic phone call, and one of the load balancers had a problem, and it went down. Now, because they weren't hardware load balancers like F1s or anything like that, when it went down, it's a software load balancer made from Linux on some hardware computer somewhere, actually in an IDC. Like, this should not have been done. When it went down, the next one went down. And then when it went down, it took down both servers, both of them. So it took down 2 sets of layer 1, 2, and 3. 2 sets of layers 1, 2, and 3. The load balancers, one of them had a problem. The exact duplicate had the exact same problem when it came back up. So this load balancer goes down, automatically this one kicks in. When this one kicked in, it had the exact same problem immediately and went down. When that went down, both servers went down. It didn't matter. There was no redundancy there. He should have never been allowed to do this deployment. And then we have a Fortune 100 company, the head manager, department head, phoning me in a panic. However, that wasn't my department that he worked for, and it definitely wasn't my project, but he was so stressed out about what had happened, he phoned me. And there you go. Do not deploy your layers 1, 2, and 3 in Linux. It's garbage. And I don't believe in this Linux garbage for VPN concentrators either. They're junk. I'm sorry, it's old school. However, you are able to do that. You are able to deploy layer 1, 2, and 3 as software layers within Linux. But don't do it on enterprise. Don't do it for industrial deployments. That's not what it's for. Not anymore. Maybe 20 years ago they could get away with it. There wasn't a lot of internet traffic 20 years ago. But now, different story. You need to separate those layers. You need a dedicated firewall and a dedicated firewall hardware unit just for firewalling. And it must be redundant. Where there's one firewall, there's a second firewall. If that first firewall goes down, the second one automatically, uninterrupted, comes in and takes over the task of that first firewall. Same with your switch, same with your router. They all must be redundant, and they must be separated in their layers. So when something does happen, it doesn't take down the entire system. You could just be replacing a switch or replacing a firewall the next day with no interruptions. That's why we separate the layers into 1, 2, and 3. Now, one thing that's very impressive is Amazon does a really good job at it. I'd say Microsoft does the best job at it. For hosting, the Azur system actually has integrated layers 1, 2, and 3 as software layers on their system. Now, they exist as software layers to me as a user, but actually in the system, they are hardware. They're hardware layers in the IDC as a hardware deployment. But I'm controlling them and configuring my system as an API. So the APIs have been integrated into Azur for layers 1, 2, and 3. You got your routing, your firewalling. Your switching, it doesn't matter. You don't do any switching in Azur. Very little. Some IPing, right? That's it. So it's pretty slick. If you've ever seen Azur, they've integrated all 3 networking layers into software APIs. Really cool stuff. Now, if you're doing a deployment on a critical system, you get the proper hardware, you separate the layers, and so if there is a problem, there's complete redundancy, nothing goes down. Don't do that in Linux. Like that example I described to you, is just stupid. Oh, by the way, the same guy, his VPN concentrator went down one day. And it was one of these stupid Linux deployments. I'm sure it would be fine if there was a low level of traffic. I'm sure that would be just fine. But with this particular company that this service was for, it wasn't a low level of traffic. And that should never have been deployed on enterprise. Not to mention, they could have bought this hardware and we had, 7 engineers to run it. But instead they have this guy doing these deployments, and he's a Linux, Unix kind of engineer, so they have to pay him a fortune. So it's the same. You're deploying Linux, you're saving on all kinds of licensing, right? This guy was trying to save on hardware. That's how extreme it was. So very ridiculous. So they're trying to save on hardware, getting this guy to build all this crap in Linux. Okay? They pay him a lot of money. he drives, a brand new BMW 7 every year, gets a new one every year type of thing. Now they're paying him for this service that isn't even redundant. So what you're saving in licensing, you're paying much more than that in engineering. Okay, and if that system ever goes down, no one else has the passwords except for that guy. I promise you. We tried it one day. We tried to set up a software system within his IDC space. No way. And no one else in the company has any of his passwords or anything like that. So they can't possibly fire this guy at all. So it's totally ridiculous. So that's it for layer 1. We're going to move on to layer 2 now. Subscriptions down below, arguments down below, questions, comments. I'll get to your questions. I'll get to your comments if I like them. If I don't, forget it. I'll just ignore you.